Hi, and welcome along to Object Disoriented, a podcast about people and technologies and people in technologies. Here we're taking you behind the scenes of the world of high tech, and we're bringing our friends, engineers and developers that are sharing their stories about their career paths and how they're changing the world using technologies.
We will take you through those amazingly interesting topics, from AI to DevOps, cybersecurity, and even gaming. We will take those complex matters and make it accessible to everyone. So even if you're a junior or a senior, you should take advantage of this insider's view into the tech industry. I'm Michal, I'm a software developer in Infinity Labs.
And I'm Timo, I'm also a software developer at Infinity Labs R&D, and today we have Maria, our guest from AWS.
Hi, Maria.
Hi.
How are you doing, Maria?
Great today to record something.
Fantastic. We will talk with Maria about AWS and cloud technologies, what they are, and then a bit about her career path and what brought her to the world of high tech. So let's start with some basic understanding. What is cloud technologies and AWS in particular for regular people, those who are not developers, not engineers?
Okay. Yeah, it's a good question because I think everybody knows that there are some cloud technologies somewhere, but actually no one understands what does it mean. So I'll try to make some examples. Again, there will be very, very basic, but maybe it will give some, context. So let's say you meet with your friends to play board games in the evening, and first thing that you do, it's like a new board game, okay? So first thing that you do, you go and Google rules, because of course the whole manual is in Hebrew and you don't understand the word. So you Google and you go to some website. All this search goes through the cloud, basically. So this is, let's say, the first time you use cloud technologies. Then, for example, you are hungry and you want to order some food, so you open some application, delivery, whatever, and for sure, I don't know, maybe 99% that this application will use some kind of cloud services to provide the whole infrastructure for delivering your order. Then you're tracking, where is your courier, where is he going? And yes, of course, because it's already 1 hour since you ordered stuff. So, and you see him going through the streets and searching for your place. And also the way how this information is sent from his mobile phone to your mobile phone, it uses some services that are in the cloud. For me, it's really very hard to guess what exact services they are, but in general, yes, it will be like this. Then you, for example, open Spotify and want to listen to music because it's kind of this vibe when you need music and, to play a board game. And you open Spotify, you have recommendations. All these recommendations also, where did they come from?
It's the cloud.
Maybe, I'm not sure, but yes.
One point to Timo.
Yeah. And I don't know, then you take pictures of you sitting, playing, eating finally the food that was delivered, and you're taking pictures, and where do you usually upload them? I'm not sure, but
It's always on Instagram, maybe TikTok.
Maybe, but all this stuff also continue using all kind of services. I'm not talking about specifically AWS services, because for sure, for Meta and for Google, they have their own cloud infrastructure. But in general, all this goes through the cloud. So during your evening, you use cloud, I don't know, at least 5 times, but I'm pretty sure that it's actually, very, very natural to you to use the cloud even without knowing about it.
Nice. So it sounds like cloud is a synonym for internet. So whenever you're internet, you're most likely using some kind of cloud technologies, and
that means that basically nowadays most of our lives are on the cloud.
On the cloud.
Yes, it's kind of true.
So how do AWS and cloud technologies work on the physical level?
The physical level, yeah, when we say cloud, internet, you try to imagine, small atoms that are running around you and moving ones and zeros. I don't know, something like this, something like, I don't know, the real cloud or whatever. Mm-hmm. But yeah, it has a very strong physical support, because without it, all this magic can't happen. So in general, what is cloud? Cloud is huge data centers with a lot of servers, a lot of computers inside that knows to calculate stuff, and they are connected to the internet, to some network. Of course, they can be connected in a different way, they can be configured differently, and so on. But in general, it's like a huge building that is very cold inside because you need, all kind of cooling system for this huge amount of hardware. But yeah, this is basically the cloud, and you have this data centers all over the world, because you here, when you sit like in Tel Aviv, Ramat Gan, whatever your city, and you order food, you don't want to send your request to US, and then US will send this request back to the courier who is driving his bike and going to you.
Although sometimes it feels that that's exactly what's happening.
Yes, but this is not how it's supposed to work. So there are a lot of such data centers in the world, and recently, AWS launched finally the data center here in Israel. Yeah, and we call all the regions according to the airport names. So we have now TLV region, and it's cool. So now when you create something in the cloud as a user, so you can choose that, I will create this in a Tel Aviv region, and it will take a small piece of this computer in somewhere here in the desert, and you will use it there.
I want to talk more about those who will use those services. What is AWS and cloud technologies for businesses? Why they need them?
Okay, so you're asking about different perspective. Till now we discussed, as an average person.
We looked at the cloud from the perspective of a person who has no connection to the world of high tech. We talked about the cloud, how it's physically not a cloud, data centers. Now there are businesses who need to set up their couriers to deliver food to their users. There are businesses who want to stream music to their users. They, for some reason, are using AWS or some other providers. Why so?
There is a very nice ads for one of the databases that also has the service in the cloud, and they have this kind of slogan. They say that they work so we can work. So it's basically the whole infrastructure that the business that is somehow connected to online services, all this infrastructure, all these bricks, all these tools, they can be found in cloud, and you can just build your business logic on top of it. So if you need a database, you can take it from the cloud. If you need some storage or something, so you can also take all kind of options to store your data in the cloud and so on. But of course, all these services, they should be combined in some smart way, and you need to add your logic there. What do you want to do with this bricks, with these tools? And that is how you finally create your own service. So this is how it is usually used by business.
And can you tell us who are the major users of AWS?
I don't have precise statistics and information, but in general, there are different groups. I can't say which group is bigger, but there are a lot of huge companies that build their business online, for example, Disney or Netflix or McDonald's.
Big corporations.
Yeah, big corporate businesses. Usually they have their own apps and their own service, so they use a cloud. They don't have their own infrastructure, so they're using some third-party cloud infra like AWS or Microsoft or whatever, so depending on what they want. And yeah, I think this is the one of the biggest parts of users of cloud technologies. Then there are a lot of small businesses. Of course, we have, let's say, 10 huge corporations and then 1 million of small businesses. So, but the first group, they're using kind of a huge scale of this stuff, and small startups, they're using something very, very tiny, but there are a lot of them still. And I think that it is actually very interesting because AWS supports small businesses and startups a lot. They kind of provide all kind of free trial stuff, or I don't know, you can use this service for free till this amount of I don't know, traffic or load. So
Nice.
yeah, and
Why they're doing that? What's their interest?
their interest is to have more businesses, because when you grow, it's kind of a win-win. So you grow using our technologies, and you can focus on your business or on your needs. And so you grow and you start to use more services, and you kind of out of free trial and you start to pay. So
That makes sense.
yeah,
It's really
Logic.
a little bit okay. Good. So we have businesses, those who are like earning money through internet, and they need to use your services. What about other customers? Do you have any?
like still it's B2B, so the customer is always some business, but of course it can be some government and all kind of governmental infrastructure. I'm not very much familiar with this part, because for example, we have a separate infrastructure for US government, and I don't have permissions to touch this part. It's very, very restricted, and only special people with the, I don't know, with US citizenship and only physically come into the place where they can access it. They can actually, do stuff with this part of customers, let's say like this.
Okay, governments, very interesting. Who else?
I think that like there are a lot of industries that are using cloud currently. So, of course, again, it's all businesses. But if we speak about big sport, so, for example, I don't know, soccer and all kind of predictions of all kind of streaming around it. Yeah, like this is usually done, yes, not in in the physical level when people put the PC near the field and waiting for it to calculate stuff. Usually they do it in a more smart way, or like the last Avatar was rendered on the AWS servers. So
Best Avatar? Like one of the biggest movies that ever came out.
maybe.
But it makes sense, because like it's all graphics, and somebody
Yeah.
needs to calculate how all those particles will move, and you need huge computational power, and AWS, they're like owning 40% of the market. So
Yeah.
So yeah, you need these computing powers where you will run, your software that knows to do it, but you still need this, hardware and infra to, to run it physically. So yeah, it was done by AWS. Like it was in AWS infrastructure. So yeah, these are just examples that are in my head, but I'm pretty sure that there are a lot more of them.
Yeah, 40%, it's a lot.
40% like now of like
40,
internet
like
abstracting
30%,
the world.
30%
Like
of
the
the
biggest,
air.
It's like the biggest, I think, infrastructure in the world.
Yeah.
Maybe, I don't know. Maybe, I don't know, Railway of Canada is bigger, but I'm not sure.
Nice. Very interesting. So you have AWS running in different zones, serving users around the world. How those services are working? Maybe you can like share with some example from your work, from services that you have done. What are they about?
Okay, so I'll go into technologies now a little bit deeper, and
We want you, yes.
yeah, and
Please
if I will say something that is not clear, just stop me, and I will try to explain in
Yeah, you're a perfect guest. Thank you.
You're welcome. Okay, so I work on the service that is called Elasticache, and this service is built around in-memory database, which is called Redis. We also support Memcached, but it's I will not touch this part. It's much smaller than Redis.
Again, what is Redis?
Thanks for asking. So Redis is I said that it is an in-memory database, which means that it is basically like a huge table that computer has in its operational memory. So you don't go and write it to the hard drive. You just have it while you're running.
Okay.
So this kind of databases, they're very cool because they're very fast. Like the time that you spend when you actually go and read something from the hard drive, it's kind of a very, very heavy operation. But not usually you actually need it, because all the time, if you, I don't know, need to save this data for a very short period of time, you don't want to spend time of reading, writing, and storing and all that. So if this data is dead, okay, it's dead. I will have another data in a few seconds. So you just want to have the very, very quick access. So you don't write this to the hard drive. You just keep it in your head, basically. And each time when you have a request, like find something, find X in your table, this operation is done very, very fast. And if I have this X in my table, so I will very fast answer, okay, the X is Y. Because this is how the table works. You have like one value and another value that are connected between each other, and this kind of search through this table happens very quick.
Nice.
So this is like, and Redis is actually very good in it. So it has all kind of cool features about what information you can actually store, and it knows to store it very efficiently. Like you can store strings like text, for example, or you can store numbers, or you can store JSONs as another type of information or lists or sets, whatever. So and it knows to store it the way, so it actually takes not a lot of memory. So it knows to store it like in a good way, and also it knows to find it very fast and to work with it very fast, because you can also ask Redis, please go through the whole table and concatenate everything that you find that starts with the letter A, and it will do it for you very fast. Nice. which is very cool. So Redis is one of the most popular in-memory databases currently, and it is open source. That makes it very, very popular as well, because you can basically like go download it to your PC and install it and run. That's it. You have Redis.
Right. So you're providing a service which is around the database, right?
Yes.
What is it?
The fact that you can just install something and run it. So yeah, like why do you need a service around?
Okay, let's answer that question. If it's open source, they can download and run on my machine. Like why do I need AWS?
So you have several options of what you can do with Redis, how you can use it. Yes, you can install it on your PC and then just sit and look at it and don't turn off your PC never ever again, because you have a running Redis there. So and you don't want it to lose the connection to the internet, so you're kind of tracking if it is healthy or not. Another option is that you buy another PC, you put it near your personal PC, and also you hire another person who will sit and look at it.
Oh, nice.
Yes.
That's a great option.
Yes, but actually this is how business works, because many businesses, they actually buy a lot of hardware, they put it into some server room, whatever. They hire system administrators or how you call these people?
IT.
Yeah, they're IT, but also it's like architectures who build this, stuff. And so like there are a lot of people who are looking at Redis working and checking that it is actually doing what it's supposed to do. And you pay these people so they would do once in a while backups, for example. Like if suddenly you have, issues with the internet connection, so you will have a backup, and then you can, start not from the scratch, but from, some reasonable, timestamp.
Right. If you have blackouts or you have...
Yes, all kind of issues that usually happens, we can't avoid them, so they will happen, and yeah, you need like people and hardware that will know to survive in this environment. So this is the second option, and the third option is to say, okay, I don't want to have all these people and all this hardware because I don't have a space to keep it. I don't want to pay for it. It's not my problem. Just take my money and give me Redis.
I'm that kind of person.
Yeah, so and usually this is what businesses do. They just come to the cloud services and they ask, please give me Redis, but also make sure that first of all I have enough capacity, I have enough Redises running, because maybe I have a lot of databases that I need. I don't know, we have different streams, whatever. I want to keep them separate. Please make sure that I have enough replicas and backups. Or please allow me to migrate the Redis that I already have in my kitchen to the cloud. So, like how to do this. So, and AWS services, they provide these kind of tools around Redis to help businesses to handle the whole database. Yes, you can install it, but you need to, to keep it alive, to maintain it all the time. And this part is taken to the cloud, and this is what our service is actually doing.
Nice. And as you said previously, you also want some proximity to the user. You don't, like if you're serving from the kitchen in Israel and your customers are in New Zealand, they will pay with some time of waiting for the packet.
Yeah, there will be like a big latency, of course. And here you can say, okay, so most of, like, I don't know, I live in Tel Aviv, but most of my customers, they are in Singapore. And they want to have servers there, so they will, all their requests will run faster. So this is kind of a good example why you also want to go to cloud.
So let's go through some of the keywords that Maria mentioned. One of them was database. What is a database? It's a storage where you can store your data and organize it as you want. So all the crowd operation will be as quick as possible. What are the crowd operation? Create, read, update, and delete. Can you tell us about one feature or service that you worked on in AWS?
Yeah, I think I can. I will take something that was not very big and also that is already in production, so I can actually talk about it. So when I joined the AWS, my first project that I worked on was like we called it thread monitoring. So I'll try to explain, but again, like any terms, please stop me and I'll try to explain them in simpler words. Like Redis itself is single-threaded, which means that like when you use your PC or your mobile phone, whatever, so you can do different stuff in parallel. So, for example, you can, I don't know, search something in the browser and you have your, I don't know, Microsoft Word open, and also you have internet connection on the way, and like you can download stuff in the background and you can watch some video. So like you can do all this stuff all together at the same moment. But Redis is not like that. Redis is much simpler. It can do only one thing at a time. So if you send Redis a request, like please find me this data in your database and return to me the result, it will just go and focus on that. It is very, very focused. So, and we as a service, we need to monitor Redis health. We need to make sure that Redis is okay, it didn't crash, it didn't stop in some stupid loop, or like we need to make sure that Redis is up. So we have a separate program process that runs, and what it does, it goes and asks Redis, are you okay? Are you fine? All good? So there is kind of a health check that this service manager does, and Redis needs to answer this. So if Redis is working hard on something that the customer asked it to do, so it will not answer. Because it's basically the same request. We're just asking some specific command that Redis supports. It doesn't matter. Like we just, need some feedback from Redis, and Redis is busy. But from the customer point of view, they're doing great. Redis is working very hard, and very soon we will get good results. But suddenly, like we are in the middle, realize that wow, Redis is not healthy. It doesn't answer us. Like something is wrong, and this assumption is not correct. this assumption leads us to the situation when we mark this Redis as unhealthy. We think that something is wrong there, and we need to take actions because, like, we promised that your Redis will be healthy. So we go and start to do all kind of our cloud magic. We start to, I don't know, reboot, reset, backup, all kind of these magic words.
Cloud magic.
Cloud magic, failover, whatever, all kind of different operations, which basically leads to the Redis replacement. We stop that Redis and we give you another Redis, which is in this situation was wrong because Redis was very good. It was working hard.
Poor little Redis.
Yes, like poor Redis. And now you miss your Redis and you go and write to the cloud support. What happened? Everything was so good, but you decided just to stop my Redis and now I need to start everything from the beginning, which is not nice. So we decided to work on this kind of a pain, and this pain, it came not only from our customers, but also from ourselves, because when we replace Redis, it causes all kind of movements, all kind of workflows that can get stuck, that can, I don't know, fail, crash, whatever. So all kind of stuff can happen on the way. And the more we trigger this kind of actions, the more we suffer because we need to go and fix this stuff. So it's kind of operational pain. This is how we call it. So we understood that we have these two pains, and we decided to develop a feature that will do this thing. Now about the design of the feature. So we will start another process that will work together with Redis. It will be started with Redis. And all the threads inside Redis, especially the main thread that actually provides the whole, access to the database, it will go and once in a while register an action. Like, my last action was this kind of operation. My last action was doing nothing. I'm waiting. And this kind of action registrations, it goes to another thread, another process, sorry. And this process, just keep it in some list, in some, I don't know, like structured way. So when Redis is running something very heavy, it's a loop. So it does something in a loop. It goes through some data. So it's like, okay, this, not this, this, not this. And while it does this operations, it can each time say what it is doing. So we have all this information in the separate process. And now our service manager can actually ask not Redis, but this separate process. And this separate process is doing nothing but registering these actions. So it is much simpler work than what Redis does, and it basically can't be stuck because it's just registration. It's just writing, okay, I have this, and that's it, without processing, without saving, nothing. And our service manager can go. Service manager is also a process. It's not a physical person who goes and asks. Yes. But
I already imagined Redis like a small working guy doing the job, like digging something.
A small dwarf that is doing. So yeah, like and like service manager can go and proceed the health check through that process. It can basically say, please give me the report, what Redis is doing, and it will provide the report in the JSON format, of course. And in this report, then the service manager will go and find the last action. And if the last action was a millisecond ago, so Redis is okay. Redis is fine. And once in a while, we go and ask for this report. We check the last action. And if the last action was in some reasonable time, so we're not touching Redis. Redis is working. We know about it now.
Nice. Makes lots of sense.
But it's like a service inside the Redis, because I think that in the beginning of the conversation, you said that the Redis is single-threaded.
Yes.
So it's like a separate process that does health check to the Redis, like bottom line?
Yeah, in general, yes. Because like Redis is single-threaded because it works with one database. And I don't want to go deeper in this situation because we will start to discuss all kind of race conditions and so on and blocks.
Let's just not talk about race conditions.
So yeah, like when you have a lot of workers who are working with the same resource, with the same data, you need to start inventing all kind of mechanisms to synchronize them, and we don't want that. So Redis is single-threaded, but it doesn't mean that you can't start all kind of stuff around it that will do other stuff, and Redis actually does that. Redis does all kind of backups by itself using separate threads, which is okay because it doesn't access the same database. So we basically did the same thing. We just started another process together with Redis that will just go and register all the Redis's actions.
Okay, so we talked about the feature, but how the development cycle works while you're working on that feature, like from the moment you have the idea up until it goes to production.
Okay, yeah. So usually we start from like what we need, like why we actually need to do that. And in Amazon, there is this principle that is under every decision. It is called customer obsession. So everything that we will
Customer obsession.
Obsession, yes, very customer obsessed services. So like when we start doing something new, we need to explain why this is important for our customers. So we collect all kind of data, we create nice reports, we go to our leadership, like management, whatever, and we say, okay, we need to develop this feature. We think that it will solve this, and that. And when we get an approval, so we start with the design, which is usually like a high-level thing. So we write a lot of documentation. We write high-level design, low-level design, all kind of appendixes to high-level design and to low-level design, a lot of reviews and so on. So this part also takes, depending on the size of the feature, it can take a lot of time. You get all kind of approvals, you understand how it actually is going to work, and then after you've finished with the design, you should go and start the implementation. So you estimate how many software developers you need to do that. Like, so you have some people to do it, that people sit and start to develop, like, writing code, testing it, and so on. And after you finish with the development, usually we have kind of, how we call it, like the day when we stop writing code. We have this deadline, that's it. From this point, you don't write code anymore. So, which doesn't mean that you actually stop writing code, because then you move to writing tests. Yeah, so we start to write all kind of tests in different levels. It can be unit tests, it can be integrational tests, that if you have different elements of your feature. It can be end-to-end tests, all kind of stuff. And when everything, you finish with tests, and again, depending on the level of the feature, sometimes you have even more preparations for the production. For example, if the feature is really very, very big, so you will have, we call this ORR, which is a operational readiness review. So you actually sit and write a document why you think that your feature is ready. And
another documentation.
Yes.
So you have documentation in the design, you have documentation in the implementation.
And in the code and in the test, and then you sit and write more documentation why you think that you're done. Nice. So you actually do all kind of exercises like, okay, what will happen if this part of the service stops working? And you write it in your doc. So, okay, I thought about it, and if this happens, we will do this, this, and that. Or how you're going to monitor your feature. Like, what kind of metrics do you have that this feature is actually working and not just, eating CPU there? So you write, okay, I have this list of metrics, and so on. So this is like an operational review. It's, again, depending on the size of the feature. You can have, now we have a huge feature that we're starting to launch, and we have a separate process which is called a pen test. Pen test, it's a penetration test. So we actually ask another third-party company to come and try to break our service, and then they sit and write all kind of findings, and we need to fix findings, and we have a security checks inside our company. So it's like crazy. To prove that you're ready, it's kind of separate stuff.
Exhausting.
Yes. Yes, it is.
And then you prove that you're ready.
Yes, we are ready. Let's say we are ready. And then we start the process of deployment.
Oh my God. Deployment in AWS, before she will tell the story, as I imagine, like you have an airplane and it's in the air and you have thousands of passengers in your airplane, and now you need to go to change something inside your engine while you're in the sky.
And document everything.
Yes, and of course you need to prove that you need to do it and how you will gonna do it and all that. So what is deployment? Deployment is a process of delivery of something to somewhere, because it can be very, very different. But in our case, because as I mentioned, like we have data centers in different countries, and also in different countries we have different data centers, and all this structure is developed the way so it will not fall all together. So if you have a data center that is, I don't know, in Tel Aviv, and suddenly it fails, so not all the world with with all your cloud will not fall together with it. So all other regions will stay strong, and they will continue serving the requests and continue proceeding. So because we have this structure of regions, so to deploy something to production means that you need to deploy it to each region. So you need to go through all regions to check that the feature is ready there, to run all kind of sanity tests, or I don't know, like to make some basic checks that, yeah, in this region it still works. And then you can actually deploy it to the region. And so in some regions you can fail because there are different kinds of regions, different kinds of permissions, different kinds of structure. You can have no capacity there, no servers there suddenly, so you can't deploy your stuff.
Wow.
Yeah, so you need to overcome all these problems on the way. And also, for example, in my feature that we developed, as I mentioned, Redis had already a way to provide information that it is alive. Right, so we had this mechanism, but now we developed a new mechanism.
So you need to go everywhere and to turn it off.
What should we do? We still have a lot of Redises that are using the old mechanism. So you need, while you're thinking about developing a feature and how you're going to deploy it, you need to think if you're going to backport it, or you will start only from this specific version. And if you have one component of one version and another component from another version, how they will actually talk to each other. So it's this, complex task that you need to solve, even like when you're not deploying it yet, when you're in the level of the design. So
yeah, it sounds like the scenarios that you talk about that you document before, like sending
yes.
a code review.
Yes, you should think of how you're gonna deploy it and what will happen when you actually come and enable this feature in production in some, I don't know, first region, for example.
Mm-hmm.
Okay, so maybe at the end, changing something in the engine in the plane that it's in the sky might be easier than deploying it. Other term that we mentioned was race condition. This one is more tricky. Usually it happens when you have some operation that runs in parallel in your computer, and they're competing for something in an unexpected way. Let's make a simple example. Let's pretend that you are a simple process and your job is to go to box and open the box and pick a red apple from the box. And that's your instructions, because somebody who programmed you believed that by the time you get to the box, the red apple will be there. And there is other process, there is our other thread, somebody else whose responsibility is to go and to put that red apple inside the box before you will come to take it. But he or she or them got stuck in the traffic jam, or something else unexpected happened to them and they haven't delivered apple on time. But you are not prepared for the situation. You're coming to the box, you're opening, and you're putting your hand to get an apple, and there is no apple, and race condition happens.
After you deploy, how do you monitor the health of the service?
It's a hard question. Okay, so first of all, I'll try to explain you the structure of our team. It's a weird angle to start with, but you will understand. So here in Tel Aviv, we have a team that works on everything that is connected to the engine itself. We are called data plane. We are like
you have those kinds of names, like you have a lot of names in AWS.
So, yeah, of course, a lot of names. Also, we have, like, for example, when we build a project, our like building tool is called Brazil because we are Amazon. So we have all kind of weird stuff.
The most random thing I ever heard.
The most logical thing you ever will hear.
So, okay, we are data plane. And our team is very big. We have a team in Tel Aviv. We have a part of our team in Seattle. We have a team in Boston. So like in Dublin. So it's really big. And we have another part of data plane in Seattle. But in Dublin and in Boston, if I'm not mistaken, we have another planes. One of them is control plane and another one is monitoring plane. So we have a different party who is in charge of monitoring.
It's funny that you wanted to switch the engine of the plane.
Yeah.
In the previous part.
Yes. So we have all kind of ways to check if our service actually works. How it happens, we like, let's say I'll try to find something. The health check thing. Let's say that we will look at it in the old way without this new feature. So we sent a request to Redis and it didn't answer. We think, maybe it is unhealthy, and we raise a metric. We say that, okay, it was the first time when Redis didn't answer. We will ask again, Redis, how are you? And Redis will not answer again. And we will continue raising this metric. And we have a definition of the alarm that will be raised if this metric will reach some specific number. So I don't know, if Redis doesn't answer 10 times, it means that something is very bad going on there. We need to take a look. And so we have this kind of monitors that just collect all kinds of metrics that we have in our service, and they put them together and create this kind of alarms. What can happen if there is an alarm? First of all, the alarm can trigger all kinds of automatic actions, automatic workflows. I don't know, the example of replacing the Redis, it's kind of the example of how we can react to some alarm. But for many things, we don't have the automatic solution. We don't know what exactly is going on. Maybe everything is completely fine. We just need to take a look. Or, I don't know, we can act differently and we don't have a way to differentiate what kind of action we should take. So it should be, a decision of an operator and not the automatic one. So this alarm can cut us a ticket. And this, when there is a ticket, someone should go and check it. So we are in the point when we need to have people who are in charge of working with these tickets. And we have a separate duty inside the AWS, which is called on-call. So it basically means that you should be ready to treat tickets. You should be ready to open your laptop, to be near your PC, to have access to all the services, to go and check what's going on and to take specific actions according to all kind of instructions to fix the situation. Or also we have tickets from customers. Sometimes they have questions or some kind of emergencies or whatever that also cuts tickets, and we also need to go and communicate with customers, understand what's going on and help them.
So just to make sure that I got it correctly, there is some responsibility that you're having from time to time to sit on call, meaning like to be busy waiting for something to happen, and once it happens, to take care of it, correct?
Yes, exactly.
How frequently it happens?
Like it really depends. Like for me, it happens like in our team. This is how it works. We have like 1 week on call, only working hours, which is again like it's we call it follow the sun thing. So it's from 8 to 8. So it's not exactly like working hours, it's a little bit more. Because after the operator in Tel Aviv finishes, there is another operator in Seattle who starts. So it's like follow the sun thing. And I have this kind of shifts once in 2.5 months or something like this, but it really depends. It's like this in our team. In Seattle, they have another system because they have more people, they have different structure. Like they decided that they want to have 2 people on call together and not one. So it really depends. It's kind of a management decision.
But it's during the day, or you can get an all-call also at night?
So because we're providing 24/7 service, so we... like the on-call that we have regularly, it's just the daytime. Because then we have Seattle who will go and help us. But if, for example, now we're going to launch a new product that we developed, like Tel Aviv developed, so there is a high chance that we will have only a night on-calls, because Seattle is not ready to maintain this product yet. But again, it doesn't mean that you need to sit near your PC like all night without sleep and so on, not eat, not nothing. No, it means that you will get paged. So we have an application on our phones that even if you turn off all notifications, it will still find you. So this kind of a application, like a pager. So we get these pages and we go and we can check stuff. Of course, if it is night, so we'll not treat customer questions. We have all kind of priorities of these tickets. So we have like severity 1, severity 2, severity 3, and depending on the severity, yes, or you should treat it at night or like at any time or not. But usually it's like it's day.
And do you have protocols, like how much time you have to get to your computer before you answer?
Yes, of course, it's Amazon. Of course, we have all kinds of documentation about it. So yeah, like I don't remember exactly, but I think that I need to check into the ticket like in 15 minutes or something like this. Maybe, I'm not sure. Like you want to check in faster because it's very annoying. Like you want to do it really fast. And also there is all kind of escalations if you didn't check in, so your secondary will get paged. If your secondary didn't check in, so your manager will get paged. So there is this kind of escalation. So, someone will actually look at it at some point.
Okay, and if you talk about Israel, even when there are like rocket alarms that are happening, you can still be on call. And
that was funny, actually. I had this question during the last escalation here in Israel, and I asked like in one of our channels at work, so what, okay, I'm on call. If there is an error alert, what should I do if I have a SEV2 ticket? And the answer was, of course, take care of yourself. You should not sit and treat the SEV2 ticket if you need to go to the shelter. No such thing. Like, we are all people, we understand what's going on. So, but yeah, I know a lot of stories when you have like a call with a customer about some ticket or something like this, and then suddenly you have an error alert. So you're saying, sorry guys, I understand that your Redis is not healthy, but I need to go to the shelter. And usually it confuses our customers a lot because, yeah, it's kind of our specific.
Okay. Great. Now I want to get back to development process. So you're an engineer, you are working with the code. We are eager to know what kind of tools and technologies you're using, which programming languages you're using to get things done.
I think that, first of all, we're kind of full stack developers, but not the full stack as you think about it when you think about web, for example. Because usually you say full stack, it means that, okay, you can start the web page and also write some...
Make a button.
Yes, make a button, and this button will go write something into database and return you. No, it's not like this. So we're full stack in our specific area of the industry. So... because we work around Redis, so Redis itself is written in C and C++, so like in C. And we write our code in Redis that we also then push to open source, of course, in C and C++. And we need to know this language. We have Java, like the service manager that I mentioned, it is written on Java. tests, Python, of course. We have a lot of stuff now written in Rust because it's kind of, it's a very cool language. It kind of solved a lot of issues that C and C++ had. And now it moved all the memory management to be checked into compile time, which is very, very nice. I really like it. So we write a lot on Rust. Also, if you build infrastructure, like you use the AWS CDK thing, like it's a kind of a toolkit that you use to create all kind of resources that you need for your project in the cloud. So there is TypeScript there, and also a lot of infrastructure in Ruby. So like we don't have, something that, okay, every day I use only this. There were 3 months that I was writing on Rust. Now, because I'm writing tests, I moved to Python, and then I don't know what I'm gonna do.
And who decides which technologies you will use?
No, but usually it depends on the purpose, because all these languages, they're like tools that you choose depending on what you want to do with it.
But you're free to choose whatever technology you want, or
but
like your team leader will say to you.
Wow, team leader will not tell us anything. Like in Amazon, there is no such thing that this is like a single person decision. So if you start a new feature from scratch, there is no infra for that. There is no same thing that someone already did, and you're not adding something to something. You're writing completely from the scratch. This is a very, very rare situation. So it means that you start a new product or something. So now we're working on the product, and there was a lot of discussions between what language to choose, and it actually took a lot of time to decide that it will be this language and not that language. But it was, it was a decision of many people. Many people said many times, had a lot of discussions, and they finally realized, okay, so yeah, we go this direction.
So you decided after brainstorming, like a lot of.
But again, it's not a one.
Yeah, of course, the whole group.
It's a very long process. You have a lot of meetings with different people, with different stakeholders, with principal engineers of different levels of, different parts of our service. So you write, again, all kind of documentation. In our documentation, we usually write, there is like this style of Amazon documentation when you need to write different options. So you want to develop this feature, what options you have to do it. So you can go for C++, and you describe what are advantages and disadvantages of C++ in this specific case. Or you want to go for C, or you want to go for Rust, or you want to go for something else. And for each part, you write why yes and why no, and then different people look at it, discuss it, and so on, and then there is like a final decision. But yeah, usually you are not the one to choose. Usually when you're like in the beginning of your career in Amazon, you basically are given this stuff that someone somewhere decided before you. But yeah, like if you have the whole infrastructure for tests, so you will just use the same one in the same language. So.
Amazon is one of the biggest companies that there are out there, and I know that a lot of software developers are eager to work there. And I wanted to ask you, how did you get in?
Okay, I'll try to answer. Amazon, it's the second place where I work in Israel. The first place was not a very big company, also high tech. I worked there for 2 years. And after I finished my second year there, I was thinking, what should I do next? Or should I stay there, or should I, try some other opportunities? And I started to, look through LinkedIn and all that. I even had several interviews for different companies, but I realized that, it's like changing something that is fine to something that you don't know. So, it's a weird decision. And if I actually want to change my job, so I need to go for something completely different, but I'm still a software developer. So I remembered that suddenly I had this idea that I want to try to apply for some position in Google. And I have friends in Google, so I wrote to her. I asked like if she thinks that it's possible, and like because for me it was kind of like, no, where is me and where is Google? Like, you know, only very smart people work there and not me. So I wrote to her, and she said, yeah, like, of course, what's the problem? You know, there are people working in Google, so you are a person, so probably you can do that. Yeah, it was kind of an obvious answer. So I talked to her, and it was like completely another world, like of the whole preparation for interviews and the CV and so on. So she helped me a lot to go through this process, because like I needed to rewrite my CV completely from the scratch.
Why so?
Usually these big companies, they receive a very, very like huge number of CVs, and usually it's not real people who are sitting and reading them in the first stage of the application. So when you go to LinkedIn, for example, and you press the apply button, or you go to the website of some specific company and you apply from there, usually your CV doesn't go directly to HR, to recruiter. It goes through all kinds of filters. So you need to make your CV to go through these filters. You need to have very specific keywords there that will be appropriate to this position and so on. So you need really to adjust your CV. But then let's say you pass these filters and now there is an HR there sitting and reading that. Again, a lot of CVs there, and they really need to understand that, yeah, I want to talk to this person. So you need to write your CV the way that it will actually stand out somehow. It doesn't mean that, you know, you need to put all kind of emoji there and, I don't know, big picture of you, something like this. It means that you need to speak the language that the HR from the big company will understand. So they will go, read it and see, yes, this person fits good to work in this company. Because from the CV, I see that they understand the specific of the business. So when you write a CV for big companies, and actually it's true for all companies, that will really help to make your CV better, is to focus on the scope and on the impact. Mm-hmm. So you're not writing something like, I developed CRM system for 3 years. Or I used several programming languages, C/C++/C#. Like, because listen, like there are a lot of people who do that. So what about you? What you actually did? And it is always better to say that there was this kind of problem that I tried to solve, and this is what I did, and this is the result. So, I don't know, I implemented the feature that reduced the operational pain. Like, I don't know, we had 10 tickets every hour. Now we have 3 tickets every hour. Something very, very specific, even though maybe it sounds small, but still it shows how you actually think about the stuff that you do. It's not just writing code. It's really solving some business issues, business purposes. So I rewrote my CV completely. Also, you know, you need to format it in a nice way, not just, you know, like simple Word and all that. So I worked a lot, you know, on the formatting and these templates and so on. So really, and also we did a lot of reviews with her. Like I sent to her, she checked, she returned it to me, and so on. And then I updated my LinkedIn according to my CV, so it will, you know, match each other. And I applied to one of the positions in Google, but Amazon just found me in LinkedIn. I didn't apply there by myself. They just, like, the recruiter found me and wrote to me, like, maybe you want to try. That was really very strange, because in the description of the position, it was written that you need to be 5+ years level experience and so on, and it was not applicable to me by that time. So I was like, I'm not sure that I should do that. And she said, no, it's fine. Like, I read your CV, you are okay, but I don't have 5 years experience. No, you're fine.
Nice. So they invited you, and now let's talk about the interviewing process.
Yeah, okay. So before the interviewing process, you actually need to prepare for the interviewing process.
Right.
And like they usually send you basic stuff about what will happen, but I also read a lot in the internet because you just need to understand what's going on with you now. Otherwise, you will just fail because you didn't know. There's as you're going to be a software developer, so of course there are a lot of technical interviews. Again, depending on the level, there are different kinds of interviews, like system design, for example. I didn't have by that point system design interview because I was like the lowest level possible ever. Like we have these grades, so I was the lowest grade for the full-time software developer, and I had only coding interviews. Which means that like how this thing works in Amazon specifically, because in different companies it works differently. So in Amazon, there are several interviews. Usually for the level that I was applying to, there were 4 interviews, technical, which means that usually you have them all together in one day. So it's like 4 hours interviews together. I mean, like 4 interviews for 1 hour each. And you can split them in 2 days, but I don't know if people do this now or don't, but I did it all in 1 day. But wait, you also have a screening interview. I forgot. So first you have a screening interview, also technical. So it's an interview, just a normal technical interview where you need to solve some coding task, and you can pass or not pass. And that's it. If you didn't pass, so this is the end of the process for you. And also inside in Amazon, this is just in Amazon. In the technical interview, there is a part that is connected to the, it is called leadership principles of Amazon. So they basically check if there is a match of the values with you and with the company. So they're checking, it's part of the behavioral interviews. So they basically usually check how you behaved in some specific situations. And so they assume that this is the way how you're gonna behave in the future. So for example, they can ask you if you ever were in this situation when you had a conflict with your manager. And you need to tell them a story when you were in the conflict with your manager. Or tell us about a situation when you didn't have enough time to deliver the highest quality. So what did you do and how did you handle this situation? So all kind of these questions, and so they check if your answers sounds reasonable for them according to the principles that Amazon has. And technical interview. So this is like the structure. Then the screening interview. If you passed, you continue and you go for this loop of 4 interviews. And these 4 interviews, they are exactly the same, but you have different people who are interviewing you. So the main idea here is that you need to have more than one opinion. So if you just fail one interview, so like maybe something just went wrong. Maybe you would do better in another kind of task or with another person, even though they're really trying to do like it independently from your personality, but still like maybe just something went wrong. And so you have this loop of interviews, and then after several days they return to you and they say if you like passed or not. Like, as I'm now in Amazon, I know what's going on in these few days. In these few days happens this thing. People who did interviews for you, they separately, like without talking to each other, they like fill the protocol of what happened during the interview, write all kind of notes, and they vote basically. So they say, they mark in the system if they think that they should hire you or they should not hire you. And also there is like a principle of how you decide if you should hire or not, because it's also not a simple thing to decide. There is this idea in Amazon that the person that you are hiring now should raise the bar, which means that they should be better than 50% of your current employers on this position. So taking this person to work with Amazon should increase the level, should, make it better. And so each time when you decide if yes or no, so you need to ask if this person actually performed better than people that are working already with you. And then these interviewers, they have the debrief, it is called. So they gather together in one meeting and they discuss what happened and what leadership principles each of them checked and how it went. And usually if it is like a high-level position, there is also like a separate person who is a bar raiser. So it's a person who probably didn't interview you. He's just there to check if this person, according to what people are saying there, is actually raising a bar. So, and all these people sit together and discuss, and in the end they vote again. So in the end, they again, maybe during the discussion they changed their decision and it's completely fine. And in the end, like they discuss yes or no. And according to this decision, they just go to the HR and say, okay, yes, we want to hire, or no. So that's it. That's the process. And if yes, so you get a nice offer and you are very happy.
Amazing. Thank you for sharing how it works from both sides of the process. That's very interesting. I have a personal question. We started our software development career together 5 years ago through Infinity Labs training. How was it for you? Would you 5 years ago believe that by now you will be a senior developer in AWS working with all these all-stack technologies? How was it for you?
I don't think that I actually thought about it because, when we started our course, I had just made my Aliyah, and I was just trying to start working somewhere without, this huge dreams of going, into some high salary and fancy offices and whatever. So I don't think that I expected that this is how it is going to be. And also, as I mentioned, when I decided to do this switch, I was not sure that I actually belong, but and now you say so.
So to you back then too.
So it was, I don't know, it's still weird.
How do you stay up to date with the latest trends and technologies?
I don't feel that I do. No, really, because I've never been kind of keen of technologies, so it's I don't read blogs or something like this, but I think it's just kind of around me because I work in the big company and people there, they're really cool specialists, and they are the one who are actually tracking all this up-to-date information. They're sending all kind of links that we can read and so on. So I don't need to track because it will just
your co-workers do it for you.
Yes, it will come to me from them, because really, like, working with these amazing people with a huge experience, and of course they are up to date because they're kind of building these new technologies, and sometimes we just share news about ourselves. Cool, we launched this, look, we are in the news. So
it's really cool to have such an environment that inspire you to grow and to know new things.
Yeah, like when I speak with our principal engineers, it's just crazy. I really feel that they're just telling me some fairy tales, and I can just, really, this is how it works.
So let's check different question. If there is someone who wants to join your team or AWS office in Tel Aviv or any other big corporation up there, what advice you can give to them, how they should start preparation and how to succeed?
First of all, I think that you should master at least one programming language. You should be very good in this programming language. Don't, try to suddenly start to study Python just because someone told you that Python is the easiest language, or that in the interviews it's less code to write in Python. Because if you already know some programming language, just master it. Just sit and write a lot of code, try different tasks, just, know how to write very fast and very clean. Make sure that that your code shines, and this is like the technical part. You really need to do that, because you just you can't just be a very nice person and have a high charisma skill to to pass an interview there. You really need to do stuff. So this is the first thing. But again, you never know when it is enough. You never feel that, okay, now I am the master of Java, now everything can be solved. No, don't go too far here. Just believe in yourself that you can. When you don't think a lot before starting to type, it's basically a good sign. If you need to write a loop or a condition or something like this, so you sit and write and it goes smoothly, so it's kind of a sign that you are ready. And this is technical part. And about the personal stuff, about the how to prepare, it really depends on you, because again, a lot of people are working in these companies. They all are very different. There is no one solution for everyone. So if you need to work hard for 2 weeks to solve all kind of interview tasks and you think you're ready, good, this works for you. If you need first to read all kind of blogs or something like this, I don't know, it really depends on your approach of how you feel. And also because people are different and we need different people in our team. So just, read a little bit about the company, read a little bit about the values there, check if it actually, fits with you. If you feel that, sounds reasonable and I want to try and seems like it's kind of a match. So just, be yourself if you think that this is a match. Because it's also your process of checking, because if a lot of people just don't work in huge companies because it's not a match, and it's completely fine. So it's not for everyone. But if you think that it's for you, so just try,
Okay, that's a great tip. Thank you, Maria. Thank you for this interesting conversation, an exclusive view inside Amazon. And thank you, Timo.
Thank you, Michal, and thank you to our listeners and viewers. As always, feel free to write any comments. We are going through them. We're trying to answering all of them. And share information about us. It will help a lot to share the knowledge that we're trying to explain here with many other people. And see you soon.
Bye.
Bye.